Okay, today's topic we're going to talk about vectors. As you said, you guys learned something about vectors in science. So write this down. So it turns out, as you might have learned this already, vectors, any quantity such as force, velocity, that's what you were telling me, right? Like 24 miles an hour east or something, okay? Or acceleration that has both magnitude and direction is a vector.
Cool.
So write that down. That's the definition that we're giving you. Any quantity such as force, velocity, or acceleration that has both magnitude and direction. It has to have two things, magnitude and direction. And we're going to talk about a little bit more in terms of what we mean by that, okay? Okay, so somebody read this for us. How about Jonathan? Can you read this for us?
When a boat moves from point A to point B,
Hmm?
the journey can be represented by drawing an arrow from A to B.
Hmm?
ABC with the arrow to the left. Read vector B.
Mm-hmm. Arrow to the right.
Oh,
Uh-huh.
yeah, to the right.
Yeah, so we read vector AB, Okay, so that's how we read. Now look at this vector notation, right? Does this vector notation look like something you've seen before?
Oh, yeah.
Kind of, right? Yeah, it looks like a ray, but it's not really a ray, right? Why not? It looks like a ray, but it's not really quite the ray. Yeah, yes?
It has magnitude.
No, the symbol itself, the ray symbol is similar to this, but it's not. It doesn't look exactly like this. Why?
Like,
Yeah, it only has half the arrowhead, right? So you notice the difference. Okay, it's not a ray; it's a vector. If you have the half of the arrowhead up there, does that make sense? So please be careful. Now, and it reads vector AB, and so can you read this for us? If vector AB is drawn, how about Jack?
If the vector AB is drawn in the coordinate plane,
Mhm.
then the journey can also be represented as an ordered pair.
As an order pair. And turns out this order pair is written by change in x, comma, change in y. So for example, take a look at this one right here. Look at this vector AB. We're going from A to B. How do I know that I'm going from A to B?
oh,
Yes.
that arrow.
The arrow, right? It's going from A to B. The arrow shows, right? A is the starting point, B is the end point. So the way we represent this vector as an order pair is we say 4, 3 because look at the change in x. By the way, have we talked about change in x before? And some other one? Change in x and change in y and so forth? In slope, right? So it's actually the same exact way of calculating the slope. It's just you're writing them in a different order, really, right? Because slope, you'd write what? Change in y over change in x as a ratio, right? Here, you're just writing as an order pair. It's just simply change in x, comma, change in y. You see that? So that's why this vector AB is written as, in terms of order pair, 4, 3. Do you see that? Okay, how would you write then this vector? CD. What would you write as an order pair, this vector CD? How about, yes, Katie? 5, -2 is correct. Okay. Does that make sense? So do you see how it's 5, -2? Because look at the change in x from C to D. It's 5 units, right? To go from C to D, you go to the right 5 units and go down -2. Does that make sense? So it's kind of similar to slope, but it's not exactly, right? Because slope is change in y over change in x. And slope, the order didn't matter. For vector, does the order matter? Yes, it does, because you could go, you remember we talked about vector being magnitude and direction. Direction, right, the order matters. Because you could go from C to D or D to C, it's a bit different. If you were going from D to C, what would your vector be then? As an order pair. If you go from D to C, it'll be, to go from D to C, it'll be -5, because you have to go 5 units left, and then go up 2. So it'll be -5, 2. You see the difference? So the order matters big time. Does that make sense? So since we're going from C to D, that's why it's 5, right? The change in x. We go down 2, it's -2. Okay, so does that make sense? So we could actually write this in terms of 2 order pairs, like x of 1, y of 1, comma, x of 2, y of 2, right? And you could actually write this out as a formula. Let me show you. So let's say that I have a vector, AB, and the two order pairs of AB is x of 1, y of 1, x of 2, y of 2. What would you write down the order pair in terms of these points? So remember we said vector of going from A to B is change in x over change in y. That's an order pair, right? So how would you represent change in x? Remember that triangle means change. So what would you write using these points then? One person see it? 2, 3? I want you to discuss with your team. Go ahead, I'll wait. How would you represent this using these points? So, what did your team come up with? How about Jordan? What did you guys come up with?
For AB,
Huh?
x over 2, no, x2 minus x1, comma, y2 minus.
Exactly. It's kind of similar to like, you know, the way we, right? It's kind of like the slope formula that we talked about last time, right? Change in x will be x sub 2 minus x sub 1, comma, y sub 2 minus y sub 1. And again, this time, right, unlike slope, where does the order matter?
I mean, yeah.
Yes, it does. It matters big time. So, right, the order matters, right? So if you're going from A to B, right, you got to do x sub 2 because x sub 2 is the point, right, that you're going to. A is the starting point and B is where, right, that's where you're going to, correct? So the end point, you start with the end points minus, right, the starting point. If you don't do it this way, that's why I highlighted 2 here. If you don't do it this way, it's wrong. Okay. Does that make sense? Okay. So if your point at A is right here, remember, change in x will be the difference of the x coordinates, and then the change in y will be the difference of the y coordinates. All right. May I move on? Okay. So this order pair, change in x, comma, change in y, this order pair shows you the direction, doesn't it? So then how do you find the magnitude of the vector? Well, somebody read this for us, the magnitude of the vector. How about David? Go ahead.
The magnitude of a vector AB is the length of the arrow from point A to point B and is denoted by the symbol vector AB.
Let's do absolute value of vector AB.
You can use the Pythagorean theorem for the distance formula to find the magnitude of a vector in the diagrams above.
Yeah, so look at the diagram above. So the magnitude is simply the what? Length of the vector. Does that make sense? So the order pair shows you the direction. The magnitude now is the length of these vectors. And now, look at vector AB. I'm sure a lot of you already see what the magnitude of vector AB would be. So look at the symbol. If you see the absolute value symbol over the, and then you have the vector, it means the magnitude, the length. Okay, so what would the length of this AB, the magnitude of this AB would be, guys? Narek? 5, because doesn't it make a right triangle? So you could use a Pythagorean theorem, or could you have used distance formula? Same thing. What about the other one? Go ahead, everybody. I'll wait. What would be the magnitude? Okay, so the first one is 5 because it's 3, 4, 5 triangle, right triangle. So what about this next one? Go ahead, everybody. Tell me the magnitude. Everybody find it. I'll wait. All right. So Kenneth, what did you guys come up with? The magnitude of the vector CD is what? Rad 29. How many people got rad 29? Very good. Okay, so square root of 5 squared plus 2 squared. Isn't that right? Easy enough?
Yes.
Do you see how to find the magnitude of a vector? And do you see the notation? All right, so let's move on. So let's do an example then. I give you 2 points. P is negative 5, 4. Q is 1, 2. Go ahead and find. Oh, first of all, sketch this vector. Secondly, find PQ. Now, what do you think I mean by find PQ? If I just give it to you this way, because on the test, I'm not going to tell you what it means. What do you think this means when I say find PQ? What do you think I want you to find? Yes, Hannah? The length? Actually, for the length, we use the what? Absolute value sign, right? So it has no absolute value sign. So this means they want you to find D. Guess what? The other one, which is D. What else did we find with the vector? To show the direction of this vector, what do we use? The order pair, right, exactly. And here, Hannah, this, if I give you this, then this means what? The length. Does that make sense, guys? Go ahead. So the second one is telling you I want the direction, right, by the order pair. And the third, find the absolute value of that vector, just means find the magnitude, okay? The length. Go ahead, everybody, go ahead and find this. I'll wait. All right, so sketching it should have been pretty straightforward, right? So do you all get this picture? Yes? Now, did you guys draw the arrow? Because if you don't draw the arrow, it'd be wrong, right? Because remember, vector, you have to have direction, right? As well as magnitude. So it goes from P to Q there. All right, to find, so it says find PQ, which just means find the order pair for this. Who's got this one? Reagan, what'd you get?
-6,
-6, comma 2. to go from P to Q, don't you have to go to the right 6?
Oh, yeah, 6, negative.
Yeah, 6 comma negative. Isn't that what you get? Okay, 6 comma negative 2. Right? Because you could see from the picture, right? Or if you just did x sub 2, which one is the x sub 2 in this case? 1, right? And so you do 1 minus negative 5, which is 6. And then 2 minus 4, which is negative 2. 2 minus 4 is negative 2, right? Does that make sense? So you could have used that formula, right? Does that make sense?
Yeah.
All right. What about from then the magnitude? Here, you know that to go is 6 units to the right and then go down 2. So you just have to find the hypotenuse. Who's got this one? How about, who haven't I called? How about Josh over here? What'd you get? Oh, the second part. I mean the third part. Find the magnitude of the vector p. 2 red. Can how many people agree with Josh here? Okay. All right, good. You guys are all correct. All right, it's 2 red 10. Now I have a question then. You see how these points, you could actually graph these, but do you think it's a good idea to graph these every time they ask for the magnitude and so forth? Yeah, but what if they're really, really far apart?
No.
So there should be a way of finding the magnitude without really graphing it, right? And I bet a lot of you already know. It's just simply distance formula. It's just a distance formula, right? So write this down, so if you forgot. So to find the magnitude of AB, it's just basically if you have point A has to be x comma 1, y sub 1, and then B is x sub 2, y sub 2. And if you're going from A to B, the magnitude is simply the distance formula. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Does that make sense? Isn't that the distance formula between 2 points? That's what the magnitude of it is, okay? Write that down. So the question is, if you figure out your order pair, could you use these points in here? Yes. You don't have to find them again, right? But yeah, but sometimes you have to because they may not ask you for the order pair. But yeah, if you have it already, you don't have to do it again, right? Okay, let's move on then. Somebody read this for us then. The symbol, 2 PQ, 2 vector PQ. Who wants to read this for us? How about Jordan?
Symbol 2 vector PQ
Mhm.
represents a vector that has twice the magnitude of vector PQ in its same direction.
Mm-hmm.
Vector PQ equals 3, 2.
Mhm.
It shouldn't surprise you that 2 vector PQ
Equals to, anybody want to guess? So 2 vector PQ, it just means, right, twice as long. Vector that's twice as long, right? Anybody guess? Yeah, it's 6, 4. You just multiply 2, right? Each of the change in x and change in y, right? Just you're basically extending it twice as long, right? So the change in x will be twice as long, and then it'll be double the change in y, right? So in general case, okay, who wants to read this? Kenneth, can you read this for us?
In
general,
general, if the vector PQ equals A comma B,
Mm-hmm.
then KPQ is
Equal to?
A
Okay, yeah, you guessed it. What is it? K A.
times A.
Yeah, there you go. Does that make sense? Right. So it doesn't have to be twice as long. It could be 3 times as long, right? Maybe can it get smaller?
Yeah.
How?
Half.
Half. It could be half. It could be 1/3. Whatever. Any number less than 1. Okay. All right. Okay. So, and this K vector PQ is called scalar multiple of vector PQ. Okay. Multiplying a vector by real number k multiplies the length of vector by absolute value of k. Now, when we multiply this by 2, we know that this vector, right, got twice as long. Why do they have the absolute value around k then? Yeah. Anybody? Yes.
Because then if there was a negative, then if you times by negative, you can't have a negative.
Yeah, it turns out actually k could be negative as well. And so if you were to multiply this vector PQ by negative, for example, negative 2, what do you think would happen? Yeah, it just goes to the, you're right, it goes to the opposite direction. What about its length? If you were to multiply this by negative 2, what do you think the length will be? It'll be still twice as long, but it'll go to the opposite direction. Does that make sense? So here's what they're talking about. That's why I said if k is less than 0, it says, write this down, the direction of the vector reverse as well. Okay, and this, here's a diagram that shows you.
So on our frames, like on the test, would there be like would you give us negative?
Yeah. So look at what happens if you multiply this PQ by -3. What do you think this vector is going to be? It'll go to the opposite direction and
Times three times as long.
it'll go 3 times as long. And look at, where does it start? It starts at P, doesn't it? You see how it starts at P, goes to the opposite direction? Right, 3 times as long. Does that make sense? So that's what happens when K is negative. Okay. So that's why it says multiplying a vector by real number K multiplies the length of the vector by the absolute value of K, because K doesn't have to be positive. K could be negative. So that's a nice illustration that shows you how it's 3 times as long as PQ, but it goes to the opposite direction. So vectors could be perpendicular too. So anybody want to read this for us? Two vectors are perpendicular if, how about Nico? Can you read this for us?
Two
Mm-hmm.
vectors are perpendicular if the arrows.
Representing them. Oh, arrows representing them have.
Representing them have perpendicular direction.
Mm-hmm. And what do you think parallel vectors will be? Yeah, Jordan? Yeah, so, okay, Jordan, why don't you read this for us?
Two vectors are parallel if the arrows representing have the same direction or opposite direction.
Opposite direction as well. So it's kind of interesting. Here's some picture. So you would think that, well, opposite direction, are they really parallel? They are. Okay, so take a look at these examples. These are all vectors that are parallel. Look at DE and AO, right? They're opposite direction. They're still parallel. What do you know about these two, AO and BC? Are they still parallel? Yeah, like it's so in that sense, it's not like parallel lines, right? Parallel lines can't be collinear, but for vectors, they could be. It doesn't matter. So Hannah, why don't you read this for us? All the vectors. Go ahead. Yeah. Hmm? Yeah. So even though they're collinear, they're still parallel as long as they're going to the same direction. Does that make sense? And they could be also be opposite. So Hannah, no? Okay, look. What is the direction that it's going here? Do you see how they're all going the same direction, Hannah? Well, if you want, you can look at their slope. Okay, look at each of the slope of the vectors. Right? They're all same, aren't they? They're all 1. Right? So therefore, they're all parallel. Does that make sense? Okay. Are you okay with that? So they all have the same slope. Okay. All right. So let's do some. Let me tell you one other thing here. Two vectors could be equal. Are equal if what? How about who wants to read this for us? Go ahead, Leah. Can you read this for us?
Two vectors are equal if they're the same magnitude in the same direction.
Mhm.
In the diagram, vector BC is equal to the vector FG.
There's C right here, and then FG. You see they both have same, not in direction, but same magnitude also as well. So if they have because that's how we define vectors, right? It has two components, magnitude and direction. If they're both same, we say the two vectors are equal. Is that okay?
Yes.
All right. So let's do some more examples. Okay. So it says example A. Show that 9, 6 and -6, 4 are parallel. Okay. How can I show that? By the way, how do I know that we're talking about vector, not a point? Because these two points, right? These two order pairs could be 2 points, right? How do we know that these are not just 2 points? Because sometimes people ask me that question. How do I know that we're talking about vectors, right? How do we know if we're talking about a point, right? Because they look the same. They're both represented by order pairs. How would you do that? Yes.
Points can't really be parallel to each other.
Exactly. Points can't be really parallel to each other. So you know in this case that we're talking about vectors. Does that make sense? All right. So it should be pretty obvious to you whether we're talking about a point or a vector. On the test, I'm not going to tell you because you should be able to identify when we're talking about vectors or points. All right. So how would you know that these are parallel? Well, you just look at their You just look at their slopes, right? So what is the slope of the vector 9, -6? Remember, this is change in x over change in y. So to find the slope of that vector, it will simply be change in y over change in x, right? So what's the slope of 9, negative 6, class? Negative 6 over 9, which is? Negative 2 over 3. Okay, what about negative 6, 4? Go ahead, everybody figure this out. I'll wait. What's the slope of that one? And are they parallel? Okay, Emily, what is the slope? So we got the slope of the first one is negative 2/3, because it's negative 6 over 9. What about the other one? Negative 6, 4. What's the slope of that vector, Emily? Negative 2/3 again. Why? Because?
Or no, 4 over negative
4 over negative 6. That's what we're trying to show, that they're parallel. And they both have the same slope, right? Does that make sense, guys? Yes? I want you to notice something interesting about these two vectors, though. Are these two vectors going same direction or the opposite direction? They're going to opposite direction, aren't they? Look at the first one. You go to the right unit, 9 units, right? And then go down 6, right? So it kind of goes this way, left to right, doesn't it? What about this one? You go to the left 6 and go up 4, and so it's going to direction from right to left. But they both have the same slope. So even though they're going to the opposite direction, right, they're still parallel. Does that make sense? Now, the second one says 9, negative 6, and 2, 3 are perpendicular. Well, how do we show that they're perpendicular? Again, you look at their slope, right? So how would you do that? What's the slope of 9, negative 6? We already know that is simply 2/3. What about the slope of 2, 3? Reagan, what's the slope of the second vector, 2, 3? So remember, this is change in x over change in y, right? So what's the slope of the second vector? Slope is change in y over change in x. So slope of the second vector is no, actually, if you look at, these are vectors, right? 2, 3, right? So this is change in x of this vector is 2. Change in y of this vector is 3. So the slope is simply 3 over 2, isn't it? Yeah, you don't have to do any calculation. If they give you the order pair for the vector, they're giving you the change in x and change in y. So you just write into the same ratio of change in y over change in x. So it's simply 2/3, isn't that right? I mean 3 over 2. Right? Because 3, the y coordinate tells you the change in y. So Reagan, are these two vectors, are they perpendicular?
Yes.
How do you know?
They're
Opposite,
opposite.
reciprocal, right? When you multiply them together, you should get negative 1. Remember that theorem we talked about? Does that make sense? So that's how we show that the two vectors are perpendicular. Easy enough? Does that make sense, guys? Okay. All right. So take a look at the one we just did here. We had two vectors, 9, negative 6, and 2, 3, right? We knew the slope of this was negative 2/3, right? And slope of the second one vector was, what was it, 3 over 2? Now, how can you show this graphically? I want to see whether they're really perpendicular. How do I even graph the first vector? 9, negative 6. Jordan?
You could use the slope, and then you could draw an arrow depending on which is if the y coordinate is negative or positive.
Right, so here's my question. How do I then graph this vector 9, negative 6, Jordan? Where do I start? Because I only have a slope. Right, you know what I
I'm
mean?
thinking like go to 9, negative 6. And
From where? From where?
Point like 9, negative 6.
Oh, actually, this does not represent actual point 9, negative 6. It doesn't. It's just, this is a vector. That's what I'm saying. You know what I mean? So you don't start at 9, negative 6. It has nothing to do with actual point 9, negative 6. Do you guys understand? It doesn't mean this point 9, negative 6 at all. Okay? It just means this vector has the direction 9, negative 6. And we could also find the magnitude. Does that make sense? So that's what I want you to be aware of. So where do we start? Yeah.
You just pick a point.
Yeah, you just pick a point. It doesn't really matter. So the vectors, if they just give you the order pairs like this, you don't know where to start, right? Because they don't give you the actual point. Unless they give you a point, then you know where to start. Like example 1, they gave you a point, right? 2 points actually. But here, if they just give you the order pair for the vector, it doesn't matter where you start. So I'm going to start at the place where it's most convenient for me. Guess where it is? In the origin. That's where I'm going to, okay? Does that make sense? So to draw this vector 9, negative 6, I'm going to start at the origin. So I go to the right 9 and negative 6. And now if I did that, Jordan, it does come out to that point. But it has nothing to do with this, okay? That 0.9 negative 6. So it's just because I'm starting at the origin. So I'm going to draw this vector. Now, this vector, where should I put the arrows at? Yes, the bottom. It's going this way. I know it's going this way because I'm starting at the origin, go to the right 9 unit, and go down 6. Does that make sense? And let's graph 2, 3. I could graph this anywhere I want, but I'm just going to start drawing it at the origin. Is that okay? So I'm going to do this in red. Let me do this in red. So I'm going to go right 2 and up 3. It's kind of opposite of doing the slope, isn't that right? For slope, we do right over 1. So here, I'm going to draw this arrow vector. And as you can see, they're perpendicular. Does that make sense? But as I said before, this vector could be anywhere. I could put it over here. I could put it over here. Are they still perpendicular? Yes, they are. Does that make sense? It doesn't matter where you start, but it's kind of easy, right? When you put it at the origin like this, both of them. You see what I'm trying to say?
Yeah.
I can still put it like here. They're still perpendicular, guys, because it doesn't tell you where you start, right? So even though so they don't even have to touch, right? Like it could be out here. They're still perpendicular. Does that make sense? That's how this vector works. So it's good. It's a good idea to actually have a visual representation of these vectors. Does that make sense? All right. So knowing this, then let's move on to the next thing here. It turns out you could add vectors. Okay. So if I have vector A, B, and vector C, D, there's a simple rule. Anybody want to guess what you get? Because remember what these coordinates, these numbers mean. A, right? The first number means change in x, and the second number means change in y. So if we're adding these two vectors, guess what this simple rule will look like? Anyone? Yes, Nico? When I add these two vectors, it will be?
A plus C, comma, B plus C.
Exactly right. A plus B, comma, B plus T. Because you're just adding up all the change in x's and adding up all the change in y's. Does that make sense? So you might want to write this down, okay, because it's going to be important for you to know how to do this. So for example, let's use this simple rule. Okay. So somebody read this for us. 2C. How about? Okay, Grace, go ahead. Thank you.
Same application of adding vectors. Suppose that a jet travels from P to Q and then from Q to R. The jet could have made the same journey by flying directly from P to R. Vector PR is the sum of vector PQ and vector QR. We abbreviate this fact by writing vector PQ plus vector QR equals to vector PR.
And here's the picture. Here's PQ. Look at, let's say a jet is going from P to Q, right, and then Q to R, right? Right. The jet could have actually gone from P to R directly. Does that make sense? So someone said, wait a minute. How do we then look at the vector PR? It's simply what? Look at the change in. What is the change in x? What is the order pair for PQ, guys? PQ is 4, 1. Isn't that right? What about QR? 2, 3. So using this vector sum, if I were to add these two vectors, what is the end, the resulting vector? PQ. It'll be, look at the change in x. Isn't this whole thing? You got to go right. How many units? 6 units, because you add up all the change in x's. And then how much do you have to go up? 4. As you can see, it becomes 6, 4. Does that make sense? So that's what we mean by vector sum. Now, does it mean that these two jets use same amount of fuel or cover the same distance? No, this distance is a lot shorter, right? You save more fuel and stuff, things like that. But that's not what we're talking about. We're talking about in terms of vectors, in terms of the magnitude and direction. If you were to add these two vectors, the resulting vector will be PR. The end, where you end up, right, will be same as going to as the vector PR, right? That will be same as adding vector PQ plus QR. Does that make sense? You end up at the same place. We don't mean like actual distance that is traveled. You see what we're saying? The end result will be at the same place. Okay? So that's why some people are having trouble. Because, I won't want to go straight to PR, right? Wouldn't that be faster and it'll save you much money, right? Because it'll save less fuel. But that's not what we mean. We mean the end result, right? You end up at the same place in terms of the direction and the magnitude. Is that okay? Are we good with this? So when you add these two vectors, that's where you end up. Okay, same place. All right, so knowing this, let's do some examples. Okay. So here we go. Go ahead and find each vector sum. This is like one of the simplest one that I could ask you. A, add these two vectors, 2, 1, and 3, 4. B, add these two vectors, negative 1, 4, plus 2 times 3, 1. Okay, it's just really simple. Okay, so go ahead, everybody try, see what you get. So here we go. For A, some of you say, well, is this a trick question? No, it's very simple. So when you add up these two vectors, what do we get? For A, what do we get here? How about, who haven't I called it? I haven't called. Jason, what did you get for A? 5, 5. How many agree with Jason? Okay, he is correct. It is 5, 5. Yes, it is 5, 5. Okay, because you just do 2 plus 3, 1 plus 4, 5, 5. What about B? B, how about, I haven't called, Michelle, what did you get for B? 5, 6, because you get negative 1, 4 stays the same. Multiply that by 2, you get 6, 2, and then you get 5, 6. Very good. Now here's the important part though. Let's see whether we can understand this graphically. Okay. So let's add these two vectors, 2, 1, and 3, 4. So let me graph. Let's graph 2, 1. That's the one that we just did. Let's graph 2, 1 here. Okay. So where should we start? I don't know where to start. Let's start the origin. That's the easiest place. So let's go to 2, 1. I go to 2 to the right, 1. Okay. Don't forget about the slope for this one. Okay. Because don't do a rise over 1. This is 1 over rise this time, isn't it? If you think about it. Okay. Right? For these order pairs, it's kind of opposite of rise over 1, really. Right? Because yeah, you don't do rise over 1 for these.
Instead of changing x, changing y, then changing x, changing x, then
Yeah, it's changing x, comma changing 1. You know what I mean? So don't make that mistake of doing like slope, you know. All right, so there's my first. And then how am I going to draw my second one? 3, 4. So I end up here. So from here, what do I do, guys? Go to the right 3 and up 4. 1, 2, 3, 4 there. Okay, and here's my second vector. And let me do the resulting vector with the red one. Here. We get what? 5, 5. Isn't that what we get? Okay, does that make sense? Do you understand? All right, let's try the next one. So that's how we get 5, 5. Let's try negative 1, 4. How would you do that one? Again, I don't know where to start, so I'm going to start at the origin. It doesn't really matter. So I'm going to start at negative 1, 4. So don't I end up here, guys, from the origin? Okay, then let's just multiply that by 2. So 6, 2. So from here, this is where I end up. I go to the right 6. 1, 2, 3, 4, 5, 6. And then go up. Where? 2. So that's where I end up. And so, are they perpendicular? Well, let's look at their slope. It's 4 over negative 1. So it's negative 4, right? What about the slope of this one? 2 over 6, which is 1/3. So they're not perpendicular, are they? So it looks like it, but they're not really, are they? Okay, be careful. So let's draw the resulting vector. There you go. Is that 5, 6? Yeah, I go to the right unit 5 and then go up 6. Does that make sense? You all understand?
yeah.
Okay. Again, some people say, well, did you have to start at the origin? No. I could have started at, let's see if it selects it. Yeah. Let me try it. Whoops. I selected that. Yeah. So I could do it that way, but it's kind of, sometimes it's, there you go. So here, I could have started here. If it right? I could have started here. It doesn't matter. The resulting vector is still 5, 6. Do you see how it's going to be still 5, 6? It doesn't matter where I'm starting at. Does that make sense? Do you guys understand? Can you do something like this for your homework tonight?
Yeah.
All right, good.